I'm Charlotte Louise from Colision.com, and today I'm going to do a quick video on momentum and just a basic one-dimensional collision. So we know that the equation for momentum is just mass times velocity, and normally momentum is represented by p, so that's what I'm going to use for it. So when we have a collision, the most important thing to look at in a collision problem, because you'll almost always be given what's going on initially, is the information that you have after the collision. So in some cases you'll have that they both move off together, and that could be all they say and you'd have enough information to solve the problem. You also need to pay attention to whether or not it's an inelastic or elastic collision, because they can give you a lot more information, or a lot less information, if the kinetic energy is conserved, because then you have two equations to use, because you also know that the kinetic energy initial is equal to the kinetic energy final. And then you'll most likely, in that case, have to use both of these together and sort of combine them to be able to figure out your answer. And it's also likely that you could have the two of them colliding and not going off together, but you'll be given information such as, in this case, that the 4 kilogram mass leaves, so it goes towards the left. I have to do my L and R to figure out where it's going at, say, 1 meter per second. And that would also give you enough information to be able to figure out what the velocity of the 6 kilogram mass is and what direction it's going in after the collision. So I'm just going to do those two basic cases. So in the case that we have basically just what I've written right here, that we have both of these two coming in together. This one's coming in, the 4 kilograms coming in at 2 meters per second, the 6 kilograms coming in at 0.5 meters per second. And then we have information about what the 4 kilogram mass is doing after the collision. We can figure out what's going on with the 6 kilogram mass. So with these, just like almost any physics problem, it's going to be really important that you define what you're saying is positive and what you're saying is negative. So we're basically, everything's going on in the x direction, if you will. It's just all along that line. So here, I'm just going to say that to the right is positive, and that's normally the sign definition that we're going to go with. So here, if we look at momentum is always conserved, therefore Pi equals Pf. We're going to have initially 4, so that's going to be our m times our v, 4 times 2. And that's positive, because it's going right, minus 6 kilograms, which is going at 0.5 meters per second. And we know that that has to be equal to our 4 kilogram mass, which is leaving at 1 meter per second, but that's negative because it's now going opposite to our positive direction, plus whatever is going on with the 6 kilogram mass times its velocity. So you can call that V6F if you want to, just to be clear. So that means we have 8 minus 3 is going to be equal to negative 4 plus 6 times V6. And we can solve for that pretty easily. We've got 5 minus negative 4 equals 6, which means that equal to 9 divided by 6 meters per second. And that's a really easy way to solve that. The other option that we have here is the case where both of these collide and we know that they go off together, and that's given pretty frequently too. that after the collision, they stick together. So in that case, we also know that the momentum initially is going to be equal to the momentum finally. And initially we have mass 4 at whatever its initial velocity is, plus the 6 kilogram mass at whatever its initial velocity is. And then we just have one mass to end. We just have the two of these together at some velocity. And here we know, so I'll just call that the final velocity. We know everything except for that final velocity, so I'm just going to really quickly put everything in terms of that. I'm being a little bit more organized on this part of the problem. 4 plus 6 over di 6 divided by the mass final. And then we can just plug everything right in. So we have that equals 4 kilograms times 2 meters per second. And we still have the sign convention going to the right, so that's going to be 10.6 kilograms at 0.5 meters per second. And then all of that divided by our final mass, which is just going to be the two of them added, 4 kilograms plus 6 kilograms. And basically all our kilograms are going to cancel out if you're interested in units. And we'll just be left with our final velocity. And so that's obviously really easy to do if you're given the information that it's a perfectly inelastic collision and therefore the two of them stick together afterwards. Yeah, so hopefully that's helpful.